Hello, we have started back-to-back tutorial for the JAMB exam. We have an interesting question on the board we want to tackle under wave particle paradox. Please, if you know someone writing JAMB, recommend this channel to the person. Share this video to the person. We have started tutorials topic by topic, treating regular topics that are repeated every year in JAMB. Please tell someone, like this video and share it. Today we have wave particle paradox. That's the topic we'll be treating. What if you see this kind of question in the exam hall? How will you feel and what will you do? If electrons are accelerated from rest through a potential difference of 10 kilovolts, what is the wavelength of the associated electron? We are looking for the wavelength in these questions. Then you cannot tackle this kind of questions if you don't have background knowledge under wave particle paradox. What is wave particle paradox all about before we apply it in solving problems like this? Is under modern physics, quantum mechanics precisely, where we talk about matter behaving as a wave as well as particle. We are saying that matter behaves as a wave as well as particle. That's the word wave particle paradox. There are properties that made us say matter behaves as a wave, such as diffraction, interference. You know the properties of waves. These properties of waves, under waves we have reflection, refraction. All these properties are wave-like properties. Now the particle properties is when we talk about scattering. We have what is called Compton effect, Compton scattering. We have thermionic effects. We have photoelectric effects. Photoelectric effects. All these are the properties which you will use and explain that matter has particle as its properties, and these are for the wave. Now there are formulas you need to know. From there we are going to solve problems like this. I'm going to derive three formulas. Please, let's do it together. The first one we are going to derive is by de Broglie's wavelength. It's called de Broglie's wavelength, such that the wavelength is equal to h upon p. That's the first one. This de Broglie's wavelength has Planck's constant h, and then p is the momentum of the particle. Then from that we'll derive also that this wavelength is equal to h upon mv. mv is the same as momentum. Momentum is product of mass and velocity. We can relate this formula to electron volts is equal to half mv squared. You know that electron volts, we can have it in joules. Then you can have energy as well in joules. So if we say this is equal to this, where we make V the subject of the formula, we are going to form another formula, which is the third one. Please write them down in your formula list. Remember that physics is all about formulas, and you need to know your formulas to do well in physics. In this topic, I'm giving you the formulas that you need to master that will help you solve any problem under wave particle paradox. So we can multiply this half mv squared. If we must be, because it's an accelerating electron, it has kinetic energy. So if we multiply 2 electron volt, that these two cross multiply will be mv squared. So we can go ahead and divide both sides by m, so that if we have v squared will be 2 electron volts over n. So that v will be square root of 2 electron volts over n. You see, we have gotten a formula for this velocity. We can decide to put it here. We can decide to put it here. Then we can as well decide to replace this V. Let's put this part into this formula to get the number 3 formula. If we have 2 electron volts is equal to mv square, we can divide here by m. Remember, we can divide also by v, so that we'll have that 1 v is equal to 2 electron volts over mv. If we decide to put it here to represent 1v, we can have it that lambda is equal to h over mv. We have our m. Instead of v, we'll put times 2 electron volts over mv. That's this v. We have replaced it with this. And at this point, m can cancel n. So that lambda will be h over 2 electron volts. This v, remember this over, if you bring it up, it will be this. We have gotten number 3 formula. This is number 3. We have derived 3 formulas. This. Please note them. They are very, very important. Now let's bring in the third one into this, so that we'll get the number 4 formula, that lambda is equal to h upon square root of 2 electron volts and the mass of the electron. This is the number 4 formula which we are going to derive. How do we derive that? Remember that electron volt is equal to half mv square. So 2 cross multiply 2 times this is equal to mv square. So if we go ahead and have 2 electron volts over m, dividing both sides by m, so that we eliminate this and we'll have v square. So let's take the square root. We'll have 2 electron volts over m is equal to v. Then we have gotten v. Putting it there, lambda is equal to h over m times, instead of v, we'll put square root of 2 electron volts over m. That's putting in this v back. And for us to bring it this mass, we can have it that lambda is equal to h over, let's bring in this mass. Once we bring it in, you know it's going to be like we are squaring it, so that if we take the square root to get back this. So if we do that, we are going to have square root of 2 electron volts m square over m. That's this m square is this. When we take the square root, we'll have the m back, but bringing it back into the square root. So lambda will be h over 2 electron volts. M will cancel 1 and we'll just have 1 mass left. This is the formula we need to solve this JAMB problem. This is the formula we need to solve this JAMB problem. Now, if electrons are accelerated from rest through a potential difference of V is given as 10 kilovolts, what is the wavelength? Now, remember, we know mass of electron. We know charge of an electron. They are constant. They will all be given. And then the Planck's constant, this is a constant, it will be given. This is a constant, it will be given. Mass of an electron is a constant, it will be given. We'll put everything into the formula to get the final answer. So let's solve it. I'm going to use the formula h over 2 electron volts and then the mass of the electron. Remember that all these things are constant. Charge of electron will be given, is a constant. Planck's constant will be given, is a constant. The mass of electron will also be given. And then we have the electron volts. So we put everything. H is 6.6 times 10 raised to power minus 34 over 2 times the charge of the electron. We put in everything times V, 10 times 10. Remember to convert this, raise it to power 3, times the mass of the electron, 9.1 times 10 raised to power minus 11. So at the end, you get your final answer as 1.22 times 10 raised to power minus 11. 1.22 times 10 raised to power minus 11 meter. So this is the solution to this problem. Let's take another JAMB past question. This is the number 2 example. Calculate the wavelength of an electron. We are looking for the wavelength of an electron of mass. Mass of the electron is given as 9.1 times 10 raised to power 31 kg, moving with a velocity of 2.0 times 10 raised to power 6. H is given, is a constant. Mass of electron is already. So the first thing is to recall your formula. Formula is very, very important. There is a video I did on formulas you must know formulas before you do your exam. Please go and watch that video. Go and watch that video in less than 1 hour. That video showed all the formulas you need to know in physics. Please go and watch it and write them down. Then lambda is equal to h over mv. Remember, they won't write this Planck's constant for you like this. They will, in exam, sometimes it will be written as Planck's constant. So it's you that will know that h is equal to mv. Then you put it 6.63 times 10 raised to power minus 34 over mass of the electron. Mass of the electron 9.1 times 10 raised to power minus 31 times v, which is 2.0 times 10 raised to power 6. So if you check, our final answer will be 3.64 times 10 raised to power minus 10 meters. Hope you enjoyed the class. Please give this video a thumbs up and tell someone about Join All Digitech Academy, where we treat exam questions on physics and mathematics. Please like this video, share it, and subscribe to this channel. Thank you.